We have previously done a complete teardown and fixed the motherboard, diskette drive and the keyboard in this epic IBM PS2 P70. In this video we're going to find out if these machines can be overclocked and try to fix a hard drive. If you want to watch the previous video too, I'll put a link for you at the end of this video. Let's start by testing the hard drive, so we can install some benchmarks. The hard drive spun up. It sounds pretty good. This is the only part that's not tested yet. I've got a reference disk in the diskette drive. Okay, let's hit enter. We're being asked if we want to configure the system. I left the motherboard without the battery installed, so it has lost time and date. Okay, the system reboots. And we still have a couple of errors. It went by too quick to read. Let's hit enter again. Fix this controller error. So let's go to set features and set time and date. We're going to remove the battery again, so I'm just going to go for a random date. Set auto dim time. So this display seems to have some sort of sleep mode. Never seen that in a PS2 before. Now let's boot again. Let's enter setup again. Fix this controller error. That doesn't sound good. Let's try a cold boot. No, still an error. Ah, that sucks. Let's go to set configuration and change configuration. I don't have any experience with the P70, but I think the drive should have been installed automatically. And only in slot 3 here we've got to fix this controller. So the system does recognize it, but it doesn't seem to work. Let's try F10 and save, and then reboot. Fix this controller error. That sucks. So unfortunately we have a bad drive. Well, in that case, we need to recap a spare drive. It's pretty much a guarantee that the caps are leaking on all PS2 drives. So if you have one of these, you better check these caps. This one actually isn't as bad, but you can clearly see on the pads that there is some corrosion here. So this drive is no exception. No plastic parts here. So we can use the Rework station. If you don't have a Rework station, just buy some Chip Quick. It's cheap and efficient. It's actually quicker than using the Rework station. Okay, so this guy here is a 47 micro 16 volts. The important thing when removing these caps is to push them sideways. Never lift them up, because if they get stuck in one of the pads, you will rip the pad off the board. This guy too is a 47 micro 16 volt. On the other drive there was some corrosion on the legs of this chip here. So perhaps this chip here is bad on the other board. It's a regular 74 F245, so it could easily be replaced. Okay, and this guy here is a 100 micro 6 volt cap. Yeah, those pads don't look too bad. There's definitely some corrosion here. I've seen a lot worse than this. I had to go and get my last spool of wick from the fridge, but this wick here has started to go a bit dry, so I guess it's about time I order some fresh wick. I just noticed I have some mild corrosion on these vias too, so we might as well clean them up. And same thing down here. I think adding some fresh solder will prevent them from further corrosion. So first I'm just going to use some fresh solder together with the flux. Okay, pads are cleaning up really quickly. But these vias are a bit stubborn. Well, you know me. More flux. And more fresh solder. Yeah, that looks much better. Nice and shiny vias. And now I can remove the solder with some wick. I'm being careful not to push on the wick to avoid scratching up the PCB. Let's scoop up that flux. Yeah, these pads look fine. They seem to be completely undamaged. I've got some stuck burned flux. So let's clean with some IPA. This board has been washed already, so I only need to keep this area clean. I found a 100 micro 6.3 volt cap. That's close enough. I switched to a smaller tip, because this could be tight between the caps. But unfortunately I'm stuck with this thick solder, so I need to order some more. I'll reheat the solder and attach the new cap. That actually didn't work too well. So I switched back to a slightly larger tip again. And now we can replace the two 47 micro 16 volt caps. Unlike the original caps, there's actually quite a size difference between the two. Okay, all three caps are soldered. So just a quick clean with IPA. Okay, so we can reinstall the PCB on the hard drive. And this drive has two flat flex cables. Copyright IBM 1988. How about that? So the way I think these work is that the entire controller is actually on this PCB. And the drive is just connected directly to the MCA bus. Don't quote me, but I'm pretty sure that's the case with these drives. Okay, I swapped the drives. Fingers crossed. It spun up. It sounds good. Unlike the original drive that was 120 megs. This drive here is a 60 meg drive. So only half the size. But that doesn't matter much, as long as it works. Okay, let's hit enter. Okay, that's interesting. I was expecting it to ask me if I wanted to configure the drive, but it didn't. So let's go to set configuration. Sorry about the flickering, by the way. That's my camera's doing. The image on this display is perfectly stable. Now let's go to change configuration. And down here in slot 3 we've got fixed disk and controller. So I guess I'll just save, exit and reboot. Wow, that was slow. It sort of hanged for about 25 seconds, but then it continued to boot the ref disk. Okay, well in that case, let's boot to DOS from a diskette. Maybe I just need to be a bit more patient with this machine. Okay, for whatever reason it didn't like my DOS diskette. So is this diskette bad? Oh no, we've got a 10483. I think that's a hard drive error. So why didn't it try to boot from the diskettes? Maybe I'm doing something wrong here with the installation of the hard drive. Okay, I did a cold boot and I got a completely different sound from the hard drive. I think that was the heads moving, but I'm not sure. Oh, the machine actually boots. But all I did was to power cycle the machine. And it boots to IBM DOS 5. So that is not only a working drive, it even has a working DOS installation. Sweet! So we have at least one good drive. But now that we know it needed a cold boot, we need to try again with the other drive. Okay, same thing again. I swapped the drives and now it sounds a bit different. I think that's the sound of the heads moving, but I can't be sure. But now we've got an error, but that could be because the system is configured for the smaller drive. So that doesn't tell us much. Let's boot from the ref disk again. Let's try to run the automatic configuration and see how it behaves. I was expecting it to do this when we install the hard drive, like it would when you install a new card. But it didn't. Okay, let's go to change configuration. Down here is our drive. So I'm just gonna save, and this time I'll make a cold boot. I had an issue with an MCA card just a few weeks ago, and that card actually needed a power cycle to start working after the installation. So this isn't too far-fetched. Now we're still getting a hard disk error. Let's try to boot from a DOS diskette and run F-disk. No fixed disk present. Well, that sucks. Okay, I swapped back to the 60 meg drive. So I ran the automatic configuration and then did a cold boot. And then installed SuperEscape 1.0 and it seems to be running fine. We're getting a score of 4.7. Okay, good, so now we have something for comparison. Okay, so let's see if we can make this machine a bit faster. So I'm going to pull that original 386 20 MHz CPU, like so. And instead we're going to install the Cyrix Cx486DLC. Binding the notch, and I checked all the pins. They were nice and straight. Okay, let's flip that switch and see if it will post. Okay, it's counting up the RAM. Now let's find out how much faster it is. Okay, here we go. Let's see how much faster that magic chip is. I'm obviously skipping ahead here, not to bore you. Okay, almost finished. Let's see what score we will get. We're getting 5.1. Okay, so about 10% speed increase. Well, that's a nice boost, but let's see if we can do better. I found this app on Phil's Computer Lab's webpage called Cx486EXE. So let's run it. And it has a nice graphical interface. So I think we need to type C on the keyboard. This option will attempt to modify the CR0 register. Do you want to proceed? Yes, please. Okay, now it actually changed to cache disabled. I thought it was disabled already, so I was hoping we would enable it. And let's run benchmarks for comparison and see if we actually turn something off. So let's write and exit and run the benchmarks again. Okay, almost finished. We still have 5.1, so it didn't do anything. If it was disabled, it's still disabled. Okay, so let's get back in here and type C again. And yes. And now it's back to CD0 good. So let's write and quit and run the benchmarks again. No, we're still at 5.1. So that app doesn't seem to work on this machine. Okay, I decided to reboot the machine. Let's see if this made a difference. No, still 5.1. Okay, I grabbed another app on the same webpage. This one is called Cx486_CD. Let's give this a try. Okay, apparently this is a command line, so we're supposed to add the letter Q. CD and NV forced to 0. Internal caching now possible. Okay, let's run the benchmarks again. Okay, almost finished. No, we're getting the same score. So unfortunately, this app doesn't work on this machine either. That kind of sucks. I wonder why. Okay, let's run check CPU next to see if that gives us a clue. Okay, it identifies the Cyrix/TI486DLC. Internal clock speed 19.8. And according to this app, level 1 cache is enabled. In that case, let's pull that Cyrix out. It's a bit toasty, but not too bad. And instead, try out the TX486DLC/E. Okay, let's turn the machine on. Okay, posts. So let's run the benchmarks and see what score we get. And we're getting exactly the same score. So no difference whatsoever. Okay, and apparently the Cx486 app won't work with this CPU. We're only getting 1 bar of graphics. Okay, let's try the other app. CD and NV forced to 0. Internal caching now possible. Okay, let's run the benchmarks. So one possibility here is that the cache doesn't work because these CPUs aren't running at their intended speed. They're only running at half speed at the moment. So I think that might be our issue. Okay, almost there. These benchmarks take about 1 minute. We're getting 5.1. Okay, so this totally doesn't work at all. Well, in that case, let's put this crystal in a socket. I did search on Google, but I couldn't find anyone having tried this before. So I guess it's about time someone try this. By the way, I finally received my new nozzles for the desoldering gun. So I thought I'd show you what the issue is with worn out nozzles. So this is one of the new nozzles, and here's the old nozzle. So first of all, the hole gets much larger, so it doesn't make good contact with the pad. But even worse, it gets these really sharp edges, and they make some really ugly marks in the PCB. So if your PCB gets ugly after you have removed the chip, check your nozzle. Here's a better view. This is a bit tricky to get on camera, but this nozzle has some really sharp edges. So no wonder the PCB looks like crap after I have used this nozzle. Oh, I just noticed This crystal has 6 pins and not 4. I hope this is not a problem. Oh, these are not pins. These are unused pads. Okay, so hopefully this is just a regular crystal. Oh, I know. This board is probably made for 2 different form factors. So you can probably choose between 2 of the sets. And that is actually excellent, because I'm not sure what I have in my stash. Now let's get that crystal off the board, without making any nasty scratches. That actually didn't work. So I'll increase the temperature and add some more fresh solder, and we'll try again. No, that didn't work. So that pin is probably connected to ground. Let's try one of the other pins. Yeah, that one cleared out. How about this guy here? No, that was a stubborn one. That one was easy. I'm gonna remove the solder in these empty pads too. Well, some of them were a bit stubborn, so I'll just reflow them and try again. Wow, that was a really stubborn pin. So I'm going to add some heat with my solder station. And it still didn't work. So how about this pin here? No, that didn't work. What an incredibly stubborn board. We're gonna have to preheat this damn thing just to get a crystal out. Well, it's a bit annoying if we have to preheat the entire board just to desolder 2 pins. So let's try to add some heat with the rework station. Okay, that did the trick. Let's make sure these pins aren't stuck to the through hole. This one actually is. So I'm going to use a desoldering needle and the rework station, and it finally dropped. Well, I guess we should clear out this through hole too, since we're going to use it. I somehow managed to damage my desoldering needle, so it's all bent up. I need to order a new set. Luckily these are really cheap. Wow, that ground plane must be huge. This method always works. But apparently not on this board. So let's try to clear out that through hole from this side of the board. Yep, that totally worked. Well, since the board only has 6 through holes, I need to snip some of these off. And we now have a 6-legged socket. All pins are soldered. Let's clean this mess up and reinstall the crystal. Well, that crystal actually doesn't sit firmly in the socket. We've had this issue before, so I don't think it's going to make good contacts. Yeah, we had the same problem in the Commodore 486. So actually, I don't think this is good enough. Let's try something new today and use a regular socket and push some of the pins out. Like so. And we now have a regular socket with 6 pins. Yeah, let's try this today. Okay, I removed the machine socket off camera. Let's install this guy here instead. It looks a bit funny, but as long as it works. Yeah, this is a much better solution. This isn't gonna give us any trouble, like the machine socket did in the Commodore 486 project. The 2 pins in the middle here are just connected to these 2 pins here. So now we can either use one of these crystals or a crystal this size here. Let's do a quick test and make sure I didn't make any mistakes. Okay, display lit up and it's counting the RAM. So I didn't damage anything. Okay, so let's pull that crystal off the board and see if this machine will go as fast as its big brother, the Model 80, with a 50 MHz crystal. This CPU should now run at 25 MHz instead of 20. Okay, fingers crossed. Oh no, it doesn't post. Oh, come on. It won't do even 25. Wow, that was not expected. I was sure it would do at least 25. Wow, that sucks. Let's make sure we have good contact. Yeah, that crystal sits really firmly in the socket. Come on, IBM. Wow, that is a disappointment. So unfortunately, I think the BIOS checks the speed. And if it's above 20 MHz, it probably deliberately prevents the system to boot. So I'm afraid someone needs to hack the BIOS for the P70. Wow, that was a disappointment. Well, just for the hell of it, I installed a 66 MHz crystal, and that actually gave me a 216 error instead of a black screen. I think that's a RAM error, but it's obviously not the RAM. Or perhaps the RAM is running too fast. Before the BIOS had a chance to stop our shenanigans. Same thing with the 60 MHz crystal. And with the original crystal, it runs normal again. So unfortunately, about 10% is all we can get. Unless someone can help us out and hack that BIOS. Well, let's have a look at that broken hard drive next. So this could be one of many things. So first of all, the legs on this chip here were quite heavily corroded. So this chip here could be dead. I can also see that the pads for this chip here also have some corrosion on them. So we may not have a good contact here. The solder mask underneath these caps could also be damaged and create a short. This could of course also be sticky heads in the drive, or something even worse inside here. Let's start with the easiest thing to check. So these caps here are very close to this edge connector, so we can easily see what trace goes to what pad and check for shorts. So this cap here has 2 traces going underneath the cap. They are not shorted. So how about this guy here? It has 3 traces coming out here. Yeah, these pads here look pretty crusty. There's actually something stuck between 2 of the pins here. That actually looks like a solder ball. Let me see if I can grab it with the tweezers. Yeah, I think that's a solder ball. It's so tiny I can hardly see it. Yeah, I had to use my loop to check. That is definitely a tiny little solder ball. I'll insert a picture here. Okay, let's turn the machine on with the original drive reconnected and a reference disk in the drive. So let's go to settings, fix this controller error, set configuration and run automatic configuration. Enter and exit. And I'll power cycle the machine. Not sure if it's needed, but that's how we did it with the other drive. 10483 error, so still an error. Let's go to test. We're getting a list of stuff here. So we've got 8 megs of RAM, keyboard, parallel port, diskette drive, system board, mouse port, an ESDI fixed disk, and plasma display adapter. I think that list is okay, so let's hit yes. And unfortunately it's testing everything, so I didn't get the option to just choose the hard drive. So I'll skip ahead here until it tests the hard drive. This display must be running at some really strange frequency. And it's too bad, because in real life here it's very sharp and crispy and very orange. Okay, so apparently it doesn't show the progress. Just tells me to be patient for 10 minutes. Okay, 10 minutes later, it's running the keyboard test. And I'm actually going to do this proper, because I need to test this keyboard before I can put that lid back on. And I'm basically being asked to test every single switch. So I'll do this test and skip ahead here. Okay, keyboard tested good. So now I can put the lid back on the keyboard. Okay, it passed the tedious diskette drive tests. And now I tried to test the hard drive. And it gave us a very long error code. Please have your system unit serviced. So that wasn't very useful, unfortunately. Well, in that case, let's go for that 245. I'll add some fresh leaded solder first. Then I'll use the rework station. to pull that chip off the board. So sometimes the electrolyte finds its way inside the chip. So that's what I'm hoping happened to this 245, since the legs were quite heavily corroded. Okay, let's add some flux here and clean all the pads with some wick, like so. Now let's scoop up that flux. Now it has already gone cold, so it won't come off the board. But it's a good trick. Just use the rework station and heat the flux up. And now it's easy to remove again. Well, I found a spare chip, but this guy here is a different form factor, so it's quite a bit larger. But as you can see, this board is designed to take this size too. I'm gonna have to align this chip off camera. Let's add some flux, some solder on the tip, and then I'll drag solder all the pins. Let's be efficient and fix the corroded pads on this chip too. So I'll add some flux. I notice some corrosion on these chip legs too, so I'm gonna reflow them too. I'll add some solder to the tip and then let the flux do the magic, making sure not to push on the pins. So I'm not scraping that stuff off, I'm just letting the heat and the flux do the job. A few pads in the middle are still bad, so I'll just do this again until they are nice and shiny again. This is going to create some bridges on the chip, of course, but they are easy to remove when we're done. Yeah, some of these pads were really stubborn, but I'm stubborn too. Okay, I think those pads look fine now, so let's remove those bridges. I remove the bridges by adding more flux, then just drag soldering and cleaning the excess solder off the tip. Okay, I think this side is done. I'll do the rest off camera and then we'll inspect those pads. Okay, all the chip legs are nice and shiny now, so I'll just clean that sticky flux off. Okay, let's inspect those solder joints. Yeah, 74F245 looks good. How about this guy here? Yeah, all that corrosion is gone. All the pads are nice and shiny again. So if there was a bad connection, it should now be okay. Okay, original hard drive connected to the machine again. Let's turn it on and see what happens. If I'm not mistaken, it's counting up the RAM much quicker now. Yeah, I'm pretty sure it did. So what's that all about? We're getting a 165. 165 on a PS2 means found new hardware. Let's hit enter. If you have installed or removed an adapter, run automatic configuration. Yes, please. Warning, the description file for an adapter in slot 3 was not found. Insert a diskette with the correct file. What? What the heck is this? Does this drive need a special ADF file? I didn't even consider this. Let me check on Ardent. Well, I'm not sure what's going on here. I just assumed that ADF files for all the original drives were included in the ref disk, but maybe that diskette is bad. So let's try another copy. This copy has been patched with the XGA OPT. Let's boot, see what happens. Okay, adapter configuration error. Let's try again. No, something is wrong here. So either we are missing the ADF file for this drive, or perhaps that drive is incorrectly identified because it's broken. Okay, and after the next boot, we have a new warning. The computer had an error in the battery powered configuration data. So something is going on here. So let's try this and see what happens. Quick reference, doesn't have a battery removal procedure. Have the system unit serviced. Oh, come on IBM. You're not servicing these machines anymore. Automatic configuration is being run. And we're back at the same warning. The ADF file is missing for that hard drive. Well, I'm not quite ready to give up on this drive yet. Especially since it's not recognized by the system. Because that tells me we probably have a fault on the PCB. And not a mechanical fault in the drive. Well, we could have both, of course. So I'm going to put this drive aside for now. And we'll get back to it later. Okay, apparently this IBM has one more surprise for us, because I smell fish. So if you have been messing around with vintage computers for a while, you have already guessed what happened here. So when you heat up leaky old caps, as in when you remove them with a rework station, they smell fish. And this display here just started to smell really bad. That is one nasty stench. It wasn't smelly before, but now that we have had this display turned on for a while, it's now quite warm and toasty. And it started to smell fish. And yeah, for sure, it's this guy here. Unfortunately, I think these caps are quite expensive. But hey, we're all in this project, aren't we? So I'll order some caps and we'll replace them. When it's done, I'll put a link on the screen shortly. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out the disassembly video of this epic IBM. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.